So the first one says, if two lines are cut by a transversal, corresponding angles are what congruent? Well, in this case, they're going to be sometimes, because they're only congruent when the lines are parallel. Okay? So if they're cut by a transversal, they're sometimes congruent because they're congruent only when the lines are parallel. Vertical angles are always congruent. Okay? Vertical angles don't require parallel lines. You can just look at two lines intersecting, their vertical angles, so those would be always congruent. The next one, if parallel lines are cut by a transversal, same side interior angles are blank supplementary. Well, if parallel lines are cut by a transversal, same side interior angles are always supplementary. If parallel lines are cut by a transversal, same side interior angles are what? Congruent. Same side interior angles are never congruent because they're always supplementary if the lines are parallel. If two lines are cut by a transversal, alternate exterior angles are blank congruent. It just says two lines. It doesn't say parallel, so we know they're going to be sometimes congruent. The last one, if parallel lines are cut by a transversal, alternate interior angles are blank congruent and supplementary. Well, we know if parallel lines are cut by a transversal, alternate interior angles are always congruent. They could be supplementary if what? Only if the angles are 90 degrees. So if they're congruent and the angles measure 90 degrees each, then this would be sometimes. So what that would look like is you have parallel lines and a transversal, and pretend like those look like straight lines. And if those were right angles, then you would know that that alternate interior angle and this alternate interior angle would be congruent and supplementary. Okay? So that would be the only situation, so your answer is sometimes. Okay? Now, let's go back up and look at this diagram, and we can just consider some things, okay? Now, again, if you're talking about angles 1 and angle 6, then you cover up the bottom because you're only dealing with transversal A, and these are your two lines. Now, since these lines are not parallel, you don't know anything about angles 1 and angle 6. You know they're alternate exterior, but they're not necessarily congruent because of the fact that these two lines are not parallel. Now, if you were looking at angle 6 and angle 10, well, you can see that their transversal is this diagonal right here. Let me pick a different one. This would be the transversal for angles 6 and 10. Well, A and B, if those were parallel, then you know that, 6 and 10 have no relationship, but 6 and this angle 6 would be corresponding with this whole angle, angle 11 and 12. So 6 is equal, the measure of angle 6 would equal the measure of angle 11 plus the measure of angle 12. Okay? Because at this point, this diagonal, it doesn't mean anything because we don't know anything about that. Okay? Angle 6 would also be equal to angle 7 plus angle 8 because those would be alternate interior angles. Okay? Those are alternate interior angles, and you can see 7 and 8 and 11 and 12, those would be vertical angles. You may always use highlighters to denote your transversal if that is easier. Now, again, if we were looking at 6 and 1, while you can see that those are alternate exterior angles, since we know that these two lines are not parallel, the measure of angle 6 is not necessarily congruent to the measure of angle 1. So it's very important to see which transversal you're looking at. Now again, over here, if we were looking at this other one as our transversal, the left diagonal, this line right there, if that's our transversal, then you know that 1 and 1 would be congruent with its corresponding angle of angle 7, which would also, and it would also be an alternate exterior angle with angle 12. Okay? Now,